Good morning, class. We are looking at pre-calculus practice test number 5, module 5, covering chapters 9 and 10. Chapter 9, systems of linear and nonlinear equations. Chapter 10, analytic geometry. And we're going to start with chapter 9, systems of linear and nonlinear equations. If a system of linear equations results in two parallel lines, the system is. If it ends up with two intersecting lines, we want to know the type of system. And finally, if the system gives us a single line. So let's remind everybody of what we have seen. Inconsistent system, the system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. Here's an example. And as you notice, they have equal slopes, but different y-intercepts. That's extremely important to see. Equal slopes, different y-intercepts. B1 is not equal to B2. Also, if you were to solve it by, let's say, method of substitution or addition, we end up with a contradiction. Example, 0 equals 7, 8 equals 9, things of that nature. So that would be the first one. Two parallel lines, inconsistent system. Two intersecting lines, it's a consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. So as we look at this, the main thing is to notice they have different slopes. Third case, if we end up with a single line, that means it's a consistent system with dependent equations. What does it mean? The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. As you look at this, the two lines coincide. They are at top of each other. They not only have equal slopes, also equal y-intercepts. If we were to solve this by the method of substitution or addition, we end up with an identity such as 0 equals 0, 7 equals 7, which gives us infinitely many solutions. We are going to solve this. Let's see the easy way out. We notice if we multiply the top one by number 5, we can get rid of x. By the way, if we go with the addition, also known as elimination method, is to set up such that in the two equations, one variable cancel each other. In this case, when we do that, on the left side, everything cancels out to 0. But the right side doesn't. That means this is a false statement. No solutions. In essence, we are dealing with an inconsistent system. If we were to graph, we would get two lines that are parallel. When we look at the second example, again, the elimination method is a better method. Use substitution if x or y, either one has a coefficient of 1 or negative 1. If you want to get rid of the x, the top you multiply by 5, the bottom you multiply by 2. If you want to get rid of the y, the top you multiply by 3 and the bottom by 7. And when we do that, it gives us the new equations, in which case we notice they cancel each other and therefore there is no more y. So we add up 6x and negative 35x. That gives us negative 29x and the right side 58. Divide by negative 29, x becomes negative 2. Now, you either go back to the first or the second equation to solve the missing y. So if you go to the first one, you're going to write 2 times x, which is negative 2, minus 7y equals 3. As you notice, this is Negative 4 moves to the other side, positive 4 becomes 7 divided by negative 7. Y becomes negative 1, and that's your final answer. Just show you something else before we move on to the next. It's important to know that we used which equation to get there. We used equation 1. Must be checked with the second equation. And it literally takes a few seconds. So check with the equation you haven't used yet. When we have a system of equations in 3 variables, ultimately we use the same method. We go from 3 to 2 to 1. Now, notice you don't want to get rid of the x because none of the variables has, and none of them has a coefficient that is negative or just a coefficient which is 1, although you can, subtract them. Remember, subtraction is a form of addition. But let's go with the easy way out. We clearly see these 2. If we add up the first 2, the y's cancel each other. So equation, first let's call them equations 1, 2, and 3. Now, if I add the first and the second equation, these 2 cancel each other. So what do we get here? 5x plus 3z equals 1. So let's add up equation 1 and 2. So which equation hasn't been used yet? The third one. Now we must use the one that hasn't been used. Do you use it with equation 1 or 2? That's absolutely your choice. So we are going to use this equation and this one. So in order to get rid of the same variable, remember we have x and z, so we have to get rid of the y also in this case. So we're going to multiply this one by 3, this one by 4. And as you can see now, these 2 cancel each other. 9 and 8, 17x, 26z, 35. So now we call this equation number 5. We set it next to equation number 4. And as you can see now, we have only 2 variables. So system of 3 variables goes down to system of 2 variables. And you get rid of one of the variables, it doesn't matter which one. For example, if you want to get rid of the x, you multiply this one by 17, this one by 5, but one of them negative. So this one by 17 gives us 85x plus 51 is equals 17, and this one by negative 5 gives us negative 85x minus 130z minus 175. These 2 cancel each other. So we add up these 2 and we add up these 2. We end up with negative 79 is equals negative 158. Divide by negative 79, z becomes 2. So we got one of the variables. So we go back to either equation 4 or equation 5 to find x. So 5x plus 3 times z, which we found it to be 2 equals 1. This is number 6. And 5x plus 6 equals 1. X becomes negative 1. So we got 2 variables. Now we go either to equation 1, 2, or 3. One of the original equations, for example, the first one, replace the x with negative 1 and z with positive 2. So 3 times negative 1, this is negative 3. Plus 4 becomes negative 1 on the other side. This 2 is positive 1, okay? Plus 1 moves to the other side, negative 1. And this becomes negative 16 divided by negative 4. Y becomes 4. And now it's a good practice to put them all together. X voice. It's a good practice to do that. And remember, we used equation 1. What we haven't used, equation 2 as well as equation 3. You really should check with both. That is the proper way of doing it to make sure you've come up with the correct answer. You must check this way. All right, we are looking at this system and we notice this has two variables, this has two variables. Let's work with these two. If you multiply the top by 8, these two cancel each other. Let's do that. And we notice on the left side, everything cancels out. You end up with 0. But the right side, they add up to negative 224, which is a false statement. Right away, no solutions. You don't even have to bother with the first. In this case, if we multiply the top one by number 3, they cancel this one. And so we notice everything cancels out on the left, also on the right. So 0 equals 0, which is a true statement. What does it mean? We have a dependent system with infinitely many solutions. So how do you write the solution? If they want you to write the solution, you write x and y, and in one of those equations, you solve for y. For example, if you solve for y in this equation, y becomes negative 1/3 x plus 2/3. So this is a dependent system. Now, when we write it in this fashion, basically it means pick any x. That's your first variable, and then put it in, and that's your second variable. That makes it easy to calculate. So inconsistent system, dependent system. All right, now what about a nonlinear system? Again, we go with the methodologies that we have seen before, something that works out. We notice that if we don't do anything, we just add them up the way they are, these two cancel each other. If 4x squared is 28, then x squared must be 7, and x is plus minus square root of 7. We are dividing by 4. Now, you can use either the first or the second, it doesn't matter, equation. If you put it into second, and since it's being squared, plus minus, they result in the same thing. And this becomes 7, everybody. Because you're squaring it, you get 7. We're going to subtract 7 from both sides. Y squared is 9, and y is plus minus 3. And it is important to know that these two, they give us 4 pairs. This is how you write them. Now, you must check. How do you check? Well, we haven't used the first equation yet. You must check with the first equation. At the very least, one of those pairs to be on the safe side. And that's really an easy check. If you, for example, put this one here, when you square this, you get 7 times 3 is 21. When you put this here squared, you get positive 9. 21 minus 9 is 12. So you can even check it mentally, but you must check. How about inequalities? The best method to go with the inequalities is to change them to equalities and graph them. So We're going to change both of them regardless of what you have, less than, greater than, less than, or equal. It makes no difference. Change it to equality. Now, in order to graph both of them on lines, all you have to do, pick up pairs. By now, we know how to find intercepts. If you choose x to be 0, y becomes -2. If you choose y to be 0, x becomes 1. So that's the first one. Second case, if x is 0, y is 3. If y is 0, x is 2. Those are the pairs for each case. For this one, plot those two pairs, draw the line. For the second one, plot these two pairs, draw the line. And let me just quickly just show you those intercepts. So we have 0, -2 here. Maybe hard to see, but now you see it. This is 1, 0. It's a different color for the other one. We have 0, 3 here, 2, 0 here. And we are not done. We go back to the original and we notice this has the equality, which makes it a solid line, but this doesn't have an equality, which makes it a dashed line. So immediately change it to a dashed line. So this one is a dashed line. I like to put the equation next to that. This red one, which we changed it to a dashed line, is 2x minus y equals 2. And this blue one is 3x plus 2y equals 6. So that's an equation. Now, which side is the solution? Bear in mind there are two lines, therefore it gives us 4 regions. Okay, this is 1, 2, 3, 4 regions. However, just treat them separately, one by one, and pick a test point that is not on any of the lines. For example, 0, 0 would be the best choice since it's not located on any of those lines. So if we just plug it into the original inequalities, they become true or false. For example, if I put it in this case, 2 times 0 minus 0 is 0 less than 2. This is a true statement. If I put it here, 0 larger than or equal to 6, it is a false statement. So first, this is the point we're going to choose. And then when we do the math, this becomes true. So that means if I were to shade that, let's just stick with the red one. In fact, I'm going to go with the red one. With the red one, since it's a true statement, this side of the red line, which is sort of like a green dash line, this would be the answer for that line and that line only. On the other hand, let me use a blue one. For the blue line, the side that contains 0, 0 is not a solution because it's a false statement. So the solution would be this side, the opposite side. And when you put them together, as you can see, this is the region that is the solution. So there are 4 regions. Let me actually give them numbers. I want to make sure we for sure understand. This is number 1, this is number 2, this is number 3, and the answer is number 4. Clearly. We may have an inequality which is nonlinear, such as this one. We do exactly the same thing. In my opinion, the best course of action is to go with the equality. And as you know, the graph of this case is very simple. Y equals x squared is a parabola, shoot it up by 1 unit, and it looks like this. Clearly, this is 0. Now, what happens is that previously a line would separate the regions. Now a curve does that. So it's inside the curve or outside the curve. Again, it just pick up a test one. You can pick this one, 0, 0, or anything in between. It doesn't matter. If you plug in 0, 0, for example, 0 is larger than 1, it's a false statement. Or if you plug in 0, 2, which is here, that means replace the x with 0 and y with 2 becomes a true statement. If this is true, everything on that side becomes true. That's the answer. Don't forget, go back and look at this. If you have the equality, this is solid, but we don't have an equality. So it's dashed. So this is how you graph it. It is dashed, and this is a test point, or you can test 0, 0 and put it in. And again, I quickly show you if we did 0, 0, 0 larger than 0 squared plus 1. That means 0 larger than 1. It's a false statement, everybody. And therefore, 0, 0 is not a solution. Anything containing that side is out. So that's dealing with inequalities, whether we are dealing with linear or non-linear, the concept is very similar. Could you please read this?
A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In the stock, he has 80% and 40% acid solutions. How many liters of each in stock solutions should he mix to prepare a 10-liter mixture?
Perfect. We are dealing with what is known as a mixture problem, which means when you mix things, you keep their total weights or volumes fixed. So we need to come up with a table like this. All we have to do, plug in the info. So 80% solution, 0.8, 40% solution, 0.4, and we want 10 liters of a mixture, which is 48%. So this is 48% or 0.48, and the volume must be 10 liters. So how much of each do we need? Well, we have no idea. How about X amount and Y amount? Which right away gives us this first equation, X plus Y is 10. And that's the concept of a mixture problem. The total volume is going to be fixed. So if something is 80% acid solution or alcohol, or you name it, whatever that is, it's only 80% of it that is pure, or the actual amount of that substance, in this case acid. So 0.8 times X goes here, 0.4 times Y goes here, 0.48 times 10 goes here, which is of course 4.8. And this last column is the second equation. And as long as we have this table, we can clearly see these two equations. Practically, we're done. So we can do it by the substitution method. We let Y be 10 minus X. And we are going to replace the Y with 10 minus X here. When we distribute, this becomes 4, and this becomes minus 0.4x. These two, they add up to 0.4x. We move the 4 and subtract it from the right, becomes 0.8. We divide both sides by 0.4. X becomes 2. So if X is 2, Y is 10 minus 2. So X is 2 liters of 80% solution. It's a good practice to put it right in front of it so you know what you have. And Y is 8 liters of 40% solution. Very straightforward. And notice we use the first equation together. I highly recommend you check with the second equation. As always, check and recheck. Go ahead, could you read that, please?
How many liters of a solution that contains 15% chemicals must be mixed with 6 liters of solution containing 10% chemicals to make 10 liters of a solution containing 12% chemicals?
Perfect. We have the same situation in a sense that it is a mixture problem. We need a table. So this is a 15% solution, 10% solution. And what is given? First and foremost, this is 0.15. This is 6 liters, okay, of 10% solution, which means 0.1. The mixture is 12%, and how much of this one we don't know is X. So this is 12%. How much of the first one we have no idea is X. But remember, they are constant, so they add up, and this becomes X plus 6. Or you can say Y if you want to go with the system, and therefore X plus 6 becomes Y. Same thing, the last column is the product of these two columns as before, because the pure or the actual amount of acid, that's how you calculate it. So 0.15x, 0.1 times 6, and 0.12 times x plus 6. And this really works out that the sum of the first two must be the last one, because the actual amount of acid you can't change when you add them up, must be what you find in the mixture as well. And it's just a matter of solving a simple equation involving decimals. You can solve it the way it is, or multiply both sides by powers of 10 with two zeros. That means 100, because you have two decimals to get rid of all the decimals. It's up to you. If you keep it the way it is and distribute, you get this one. So 0.15x plus 0.1 times 6 is 0.6. If you distribute this one is 0.12x, and if you distribute this one is 0.72. So how do we move things around? We can subtract this, and that becomes 0.03x. We can subtract this, and it becomes 0.12. And if you divide both sides, you can write this as 12/3. I hope you remember how we take care of the decimals. And x becomes 4, so we have 4 liters of 15% solution. Again, we are looking at a mixture problem. Could you please read this?
A plane can travel 800 miles per hour with the wind and 720 miles per hour against the wind. Find the speed of the wind and the speed of the plane in still air. Set up a system of equations and solve.
Perfect. This is known as a motion problem. D equals RT. Is the distance, R is the rate, T is the time. Now, when we go in the same direction as the wind or the current, the speed of the wind or the current will help us, will be added to our speed. If we are going against them, they will work against us. Their speed will be subtracted from ours. So I can use any variables, but one thing that I found easy: for the plane, use P; for the wind, use W, and that makes life easy. So with, that means P plus W, and against means P minus W. As you can see, there's really not much. You have to just add up. These two cancel each other. We get 2P, and then these two, they give us 1520. If you divide by 2, P becomes 760 miles per hour. 760 miles per hour. Put it in any of those equations to find the wind of 40 miles per hour. And again, if you use the first one, then check it with the second equation. As you can see, it works. It's really simple. Could you please read this question?
Admission tickets to the Braden River Little League All-Star Game cost $4 for adults, $1.50 for children. A total of 225 tickets were sold, and a total of $500 was collected from ticket sales. How many adult tickets and how many children tickets were sold? Set up a system of equations and solve.
Perfect. It's a good practice to go with some sort of a table. And so adults, children, total ticket cost, number, total amount. We know the cost is different for adults and children. So $4 for adults, $1.50 for children. So how many, what else do we have? We have a total amount of $500 and a total number of tickets of 225. So the number of tickets, we know the total is 225 and we know the total amount, dollar amount is 500. So let's put them there. Now again, we can go with X and Y, but let's go with A and C. The initials would make life easier if we go that way. A represents the number of adults, C represents the number of children. Also, right away, this is one equation, A plus C is 225. So how much do we pick from the adults? 4 times 8. That would be the total amount we gain from the adults, and from the children, 1.5 times C. And they must add up to a total of 500. So this is the first equation. This is the second equation. And you can solve it by any method of your choice. For example, if you multiply this one by -4, that means you're going to get rid of A. If you multiply by -1.5, that means you're going to get rid of the C. So if we multiply by -4, we get -4A, -4C, -900. Let's just write the second equation as is. They cancel each other. These two add up to -2.5C. These two add up to -400. You're going to divide by -2.5. Which is the same as 4,000 divided by 25. I hope you realize that 2 zeros, that means 100 divided by 25 is 4 times 40 makes it 160. So if C is 160, A is 225 minus that, because they must add up to 225, and A is 65. And you really have to check your work. Obviously, these two numbers add up to 225, but put it into the second equation, make sure that we have come up with the correct answer. Always check your book. That's the beauty of math. You can check your book. Would you read this, please?
One leg of a right triangle is 4 centimeters less than the other leg. The area of the triangle is 70 square centimeters. Determine the length of each leg. Set up a system of equations and solve.
Excellent. So it's a good practice to have the setting. So if one is X, one is Y, this is, I mean, by drawing, this is obviously larger. So one leg is 4 centimeters less than the other. So one leg, that means X, must be Y minus 4. That's the first. Then we know the area is 70, and we know the area is 1/2 base times the height. Because it's a right triangle, then the two sides, one of them is the base, one of them is the height. And it gives us the following set. X equals y minus 4. Half of base times the height, half of x times y is 70. Now, to get rid of the fraction and make life easy, let's multiply this one by 2. So 1/2 goes away. So x times y is 140 and x is y minus 4. Replace the x. Substitution method. Replace the x. If I distribute I get y squared minus 4y on the left, and I'm going to move the 140 also to the left. So now I can easily factor in. We want two numbers. The product is negative 140. The sum is negative 4. Those are negative 14 and 10. They result in positive 14, negative 10. Sides can't be negative, so we get rid of this. So y becomes 14. If y is 14, what is x? 10. And as always, you write the units. Does it make sense? Does it work? Check it out with the second equation. Half of x times y must be 70. That's the area. So multiply this to 140. Half of that, is it 70? Yes, it practically takes no time to check. You must check. Could you please read this?
The sum of three numbers is 105. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. Find the numbers.
Perfect. First and foremost, let's define the numbers. Let's say the numbers are x, y, z. So the first one is x, the second one is y, the third one is z, or anything you want, but just define it. Now that we have this, let's go sentence by sentence. The first one says the sum is 105, x plus y plus z is 105. So that's the first one. Now the second equation says the third is 11 less than 10 times the second. The third, that means z, is equal to 11 less than 10 times the second. So 10, the second one is y, 10y minus 11. Here's another sentence, and therefore the last equation. Twice the first, so twice the first, 2x, is equals 7 more, 7 plus, 3 times the second, 3 times y. So I hope you see how we did the translation. I put them with the same color, so you see that a sentence that goes with an equation. Now notice that if z is 10y minus 11 and I put it into the first equation, then the first one has only x and y, so does the last one. So let's replace this z with this one. So equation 1 becomes x plus y plus z is replaced with 10y minus 11. Now we're going to put this together. This is x, this is 11y, and we're going to move the negative 11 becomes positive 11. So we put these two together and we move the positive 11 to the others. Now, the last equation with this one, they both involve x and y. Let's put them together and work on this system now. Again, this is a fast way of handling this. Notice this has 2x, so what we can do to make life easy, if this was 2x, we would replace the x. So why don't we multiply this by 2? Again, this is another method, a fairly fast one. Since this is 2x, instead of solving for x, keep it, multiply this one by 2 and replace it. So let's multiply the first one by 2. And now we can replace the 2x here with 7 plus 3y. That's a fairly fast way of handling this. Now, when we put these two together, we get 25y. We subtract the 7 from 232, we get 225. We divide both sides by 25. Y becomes 9. Z is a 10 times that minus 11. So 10 times that, 90 minus 11 is 79. And now you can go to the first equation or the last one and find it. If you go to the first one, just add them up, this one and this one, and the missing x must be 105, and x becomes 17. And it's really a good practice to put them in order so it becomes clear. X is 17, y is 9, z is 79.